you all are doing great. And today we will see one of the interesting chapter of grade 8, that is chapter number 2, power play. Have you heard the name of power play earlier? Yes, cricket में सुना होगा. But today we will see in mathematics as well, power play. So before starting the class, let me give you a short intro about me. I am Dhananjay, a maths master teacher at Sisya class and a postgraduate in MSc Mathematics from National Institute of Technology, Durgapur. So, if you want more such interactive courses like this, please visit to Sisya class courses where we have a booster course, Maths Jam course and Sisya Topper program that is going on currently. Okay, so simply what you have to do, just visit the sisyaclass.com/LTC. There you have to tap on your grades. Simply a pop-up will appear. In that you have to fill in your phone number and your state, okay, and you can try 3 classes at just ₹19 only, right? Very interesting. Now what are the topics that we will be covered today? This is important. The first one is what is an exponent. Second, we will see about the negative exponents and reciprocals. All 6 laws, this is one of the important ones because this is the overview of this chapter. All 6 laws of exponents, very large and very small numbers. So don't worry if you don't know the index, I will try to keep it very simple for you. Okay, standard form or scientific notation everyone knows, and at the last I'll give you some practice question or homework question as well. Okay, so let's start. What is an exponent? So in the first chapter we have studied about the cubes and cube roots, right? Cubes, cube roots, squares and square roots. There I told you that if a number multiplied by 3 times, like if the same numbers I'll multiply 3 times, 3 into 3 into 3, it is written as 3 raised to the power 3. That was basically a cube, right? So it was 27. Now, what is an exponent here? Same thing. Exponent means powers represented by a number raised to some powers. Like if I'll write here a raised to power m. A raised to the power m means we are multiplying a same number. We are multiplying a same number m number of times. Like here we multiplied the same number 3 number of times. Here we have to multiply m number of times. So a into a into a into a into a. How many? So if say m equals to 3, so we have to multiply 3 times only. But if we have m number, m can be 10 also, m can be 20 also, m can be 50 as well. So m means can be any numbers. So we have m number of times. Okay. Clear? So what is an exponent? Exponent tells how many times a number is multiplied by itself. So suppose if you have to find 2 raised to the power 4, m here is 4, a is 2. So 2 into 2 into 2 into 2, 4 times. Clear? That is basically 2 into 2, 4, 4 into 4, 16. So powers is important here. But what if a is negative? Here we have chosen a equals to 2, right? A raised to the power m. In this example, a is 2 and m equals to 4. But what if we choose a as negative? Suppose if I'll take a equals to -3, a equals to -3 and m equals to 3. What is a raised to power m? Means 3 raised to the power 3. Is it positive or negative? Tell me. This one is positive or negative? So if we have a power on negative numbers, but the power is an even number. So there are 2 classification here on powers. If we have a even power or we can have odd power, right? So here we have odd power, so it will always be negative. Clear? For even power it is positive, for odd powers it is negative. So this will be minus 3 raised to the power 3. Minus 3 raised to the power 3 means, see here, minus 3 raised to the power 3 means minus 27. So if we have a odd powers on negative numbers, it will come out with a negative sign. This is clear. So an odd powers keeps the negative sign, even powers removes the negative sign. This is clear. So if we have minus 3 raised to the power 2, so 2 is a even number, right? 2 is an even number. So minus 3 raised to the power 2 means plus 9, not negative 9. Clear? So positive power, positive number, if you have a negative number and its powers are even, so we have a positive number. If we have a odd powers, odd power keeps the negative sign. This was the summary for this slide. Okay, clear? So exponents is clear to you. Now the next one is the negative exponent. Negative exponent means if we have some negative powers like a raised to the power m, I told you, what if m is a negative integer like a raised to the power minus n, where n is a positive integer, m and n are simply integers. Okay, so don't get confused. So if n is positive integer, why I have chosen as positive integer? Because already I have chosen negative sign, right? Then only it can be negative. If n is positive integer, let's say positive integers means like natural numbers 1, 2, 3, 4, 5. So choose n equals to, let's say 5. So a raised to the power minus 5, I can write this as 1 upon a raised to the power 5. Clear? If I want to make power positive, what I'll do? I'll just write this as 1 upon a raised to the power 5. So this one is an important property. I hope you will remember it. So a negative exponent means simply take the reciprocal, then apply the positive power. Means if you want to make the power as positive, what I'll do? I'll take the reciprocal and make it positive. Clear? It does not make the answer negative. Obviously, some students, what they think that if I'll take 5 raised to the power minus 2, the answer will come out to be negative. Right? 5 raised to the power minus 2. They think that the answer will be negative. No, the answer will not be negative. It will be in fraction. So what I'll do to make it positive, I have to take reciprocal. So 1 upon 5, 1 divided by 5 raised to the power 2. That is basically 1 upon 25. Clear? So 2 raised to the power minus 3, in the same way 1 upon 2 raised to the power 3. So 2 raised to the power 3 means 8. 1 upon 4 raised to the power minus 2. This one is important. We already have reciprocals. Like in fractions we have the values. So what I'll do? Take their reciprocals first. So what is the reciprocal of 1 upon 4? That is 4. The reciprocal of 1 upon 4 is 4 only. So 4. Now the powers will become positive. So 4 square, that is 16. So just flip the fraction. If you have negative powers, you can simply flip the fraction. Very simple. So negative exponents is clear to you. A raised to the power minus n is 1 upon a raised to the power n. This one, please remember. Now let's come to the most important points of this chapter, and all the questions will be based on this only. That is laws of exponents. We have basically 6 laws that we'll study one by one. 6 laws, in which first one is the product law. Product law, it says that if we have a number, let's say a, okay, raised to some power m. If we have another number with same base, that is a only, but power is different. So a raised to the power m into a raised to the power n means if I want to take a product of these two numbers, that is common base, just add the powers m plus n. Simple. Same base, multiplying powers means if you want to multiply these two numbers, just add the exponents. Exponents means powers. You can add the exponents simply. As for example, let's say a is 3. So 3 raised to the power 2 into 3 raised to the power 4. Observe here, a is 3 means base is same in both the numbers. So simply what you have to do, take the common base, that is 3, and just add the powers. So this will be 2 plus 4. So 2 plus 4 means 3 raised to the power 6, that is 729. Clear? Next example, what if sir the powers will be negative? Doesn't matter. Let's say 5 raised to the power minus 2 into 5 raised to the power 5. I have chosen example here. 5 raised to the power minus 2 into 5 raised to the power 5. So 5 raised to the power minus 2. First apply the product law. So 5 raised to the power minus 2 plus 5 you have to do, right? So minus 2 plus 5 is 5 raised to cube. Cube we already covered in the previous chapter. 5 cube, all of you remembered, right? 125. So this is how you have to do the first law, that is product law. Once again I am repeating, when you will be given a two numbers with common base but different powers, simply what you have to do, just add the powers, right? Second law, that is quite similar to the first law. What it is? The quotient law. The first one was product law, means multiple law. This is the quotient law. It is if we have the same base and different powers, but here we have a division. Same base dividing, powers different, can be same as well, doesn't matter. Just subtract the exponents, means you have to subtract the powers. So a raised to the power m upon a raised to the power n equals to a raised to the power m minus n. Clear? In the first you have to add the powers, here you have to subtract the powers. Any doubt? No? No doubt? Clear? Okay. Let's move ahead to some examples on quotient law. First example is 7 raised to the power 5 divided by 7 raised to the power 2. Simple, right? So firstly, how will you write it? Divide. So 7 to the power 5 upon 7 to the power 2, I can write like this, obviously. So base is same here, that is 7. So if base is same, you can subtract the powers. So 5 minus 2. So 7 raised to the power 5 minus 2 is 7 raised to the power 3. So what is 7 cube? 7 cube is 343. Clear? So you have to remember the cube first, okay? If you want to do fast calculation, you have to remember the cube from at least 1 to 20, that I told in the previous classes. Next example is 4 raised to the power 2 divided by 4 raised to the power 5. 4 raised to the power 2 divided by 4 raised to the power 5. Here if you will observe, we have to use two laws, right? 4 raised to the power 2 minus 5. So 2 minus 5 is negative numbers, right? That is 4 raised to the power minus 3. Now if I want to make it positive, what I'll do? I'll take the reciprocals, right? So 1 upon 4 raised to the power 3. What is 4 cube? 4 cube is 64. Simple. So 1 upon 64 is the answer for this example. So two laws is clear to you. First one was product law. Second is quotient law. In product law, you have to add the powers. In quotient, you have to subtract the powers. Third one is a power of a power. Power of a power. What is the meaning of it? Suppose if we have two powers, like a raised to the power m to the power n. What I'll do? Here I'll not add the powers like the previous ones. I'll multiply the powers instead. How? A raised to the power mn. So take an example. Suppose we have 2 raised to the power 3 raised to the power 2, 2 raised to the power 3 raised to the power 2. So should I do 2 raised to the power 3 plus 2? No, this is wrong. 2 raised to the power 3 plus 2 is wrong. We have to multiply the powers. So it will be 2 raised to the power 3 into 2. That is 2 raised to the power 6. So what is 2 power 6? 64. Yes, that is 64. Next example. You can choose m and n can be positive, negative, doesn't matter. Okay. So if I'll choose m equals to -2 and n equals to 3. That is what I have taken here. So just simply multiply the powers once again. So if you multiply the powers, so -2 into 3 is -6. That is 1 upon 5 raised to the power 6. Which property I have used here? Can you tell me? 5 raised to the power -6 equals to 1 upon 5 to the power 6. Which property I have chosen here? Negative exponents, right? If we want to make it positive, I have to take the reciprocals. Yes, at the starting we have done this property, right? If the powers are negative, to make it positive, what I'll do? I'll take the reciprocals of that number. Clear? Any doubt? No? So this was the third law. So till now we have covered 3 laws: product law, quotient law, and the powers of a power. I hope there are no doubts to you. Next one is the combined 2 laws, that is law 4 and law 5. Powers of a product and powers of a quotient. What is it, sir? Now here the base, if you will observe in the previous 3 laws, base was always same, right? Base was always same. But what if the base are different? If bases are different, no, then we have 2 laws, that is powers of a product and powers of a quotient. What it says? It says that if we have a raised to the power m and b raised to the power m, a, b are 2 different bases, right? A, B are 2 different bases. So we can combine these 2 bases and take the power as common. But important point here is powers are common. Bases are different, but powers are common or same. So just simply multiply the 2 numbers and take the power as common. This is what you have to do in multiplication. In the same way, for division, what you have to do? You have to divide the 2 numbers first and take the powers as common. Same thing. Multiplication, firstly you have to multiply the numbers and take the powers. In division, what you have to do? Take the division first and take the powers. Simple. Like example, if we have 5 raised to the power 2, 5 raised to the power 2 into 2 raised to the power 2, 5 raised to the power 2 into 2 raised to the power 2. So what I'll do, let's observe this number. If you'll observe it, firstly let's multiply 5 into 2 and check that the answers coming are same or not. So I'll multiply 5 and 2 first. So 5 into 2 to the power 2. So 5 into 2 is 10. 10 raised to the power 2 is basically it is coming 100, right? 100. Now let's solve. this part, LHS part, if I'll solve 5 raised to the power 2 into 2 raised to the power 2 without using the property. So 5 raised to the power 2 is 25. 2 raised to the power 2 is 4. So 25 into 4 is once again 100, means the properties are correct. So A raised to the power m into B raised to the power m is, take the product first and then take the power. Simply, instead of finding it differently, you can take the product simply and find the powers. So same way you have to follow for the division as well. How? Suppose we have an example, 6 raised to the power 2 divided by 3 raised to the power 2. 6 raised to the power 2 divided by 3 raised to the power 2. Powers are same. This is important. The powers should be same. Here also in multiplication, powers are same. Bases can be different. Yes, sir. Bases can be different. Powers should be same. This is the necessary condition. So just simply divide the numbers first. 6 upon 3. Take the power common. So 6 upon 3 is 2. 2 to power 2. That is 4. Is this correct? Obviously this is correct. Now if you will find individually, so 6 square is 36. Let's verify it. 6 square is 36 and 3 square is 9. So 36 divided by 9 is once again 4. It means that this property is also valid. So 4th and 5th law, I think this is clear to you. 4th and 5th, that is a combined law for powers of a product and quotient. So 5 laws are clear to you. Okay, let's move to the last law, and that is the zero exponent. Zero exponent. Now this is not a separate law. We can prove it with the help of quotient law. See how? A raised to the power 0 is always 1. Just remember, A raised to the power 0 is always. What is A here? A can be any non-zero number. Take any number except 0. You cannot take A equals to 0. Why? I'll tell it. Firstly, take any non-zero number and take power equals to 0. It will always be 1. So this is what zero exponent says. How? How it is coming from the quotient law. We know that when we divide the same number, the quotient equals to 1. Yes, when you divide with the same number, the quotient equals to 1 only. So if you will divide A raised to the power m, once again, A raised to the power m with A raised to the power m, what it will be? Use the quotient law. If we have same base, subtract the powers. Same base, subtract the powers. But here powers and bases are same. So what I'll do? I'll subtract m with m only. So m minus m is 0. That is A raised to the power 0. But why A raised to the power 0 equals to 1? Should I write it here? A raised to the power 0 equals to 1? No. Why I'll write? Because if you will divide any numbers with the same number, the quotient will always be 1. You know, right? If you will divide 5 with 5, the value will be 1. If you will divide 10 with 10, the value will be 1. That is why I will write A raised to the power 0 equals to 1. Clear? This is the reason I'll write A raised to the power 0 equals to 1, because of the quotient law. And it says that if you will divide with the same number, the value equals to 1. Clear? This example is clear to you. So take any example. Like here I have chosen 100. So 100 raised to the power 0 equals to 1. 10 crore raised to the power 0 equals to 1. 10 lakh raised to the power 0 equals to? Obviously it is 1. Okay. Now the next thing is, can I take negative number also? In place of a, can I take negative number also? Obviously you can take as minus 15 raised to the power 0, that is 1. Minus 10 raised to the power 0, 1. Minus 20 raised to the power 0 equals to 1. Minus 10,000 raised to the power 0 equals to 1. But what if I'll take a equals to 0? So 0 raised to the power 0. These things you not need to study because this is a indeterminate form. Indeterminate form. So what is the meaning of indeterminate? This is indeterminate. 0 raised to the power 0. This cannot happen. 0 raised to the power 0. This is an indeterminate form that you will study later on. So till now, just understand that a cannot be 0 here in this law. 0 exponent, any number, take power 0, it will be 1 only, but the number should be non-zero. Clear? Now I have written all laws, 6 laws at once. Let's see one by one. First one is the product law. It says that a raised to the power m into a raised to the power n is a raised to the power m plus n. Same base, power add. Second one was quotient law. Quotient law, same base, subtract powers. Same base, subtract powers. Third one was power of a power. So if we have any number raised to the some power raised to the some power, so that is the multiplication, like a raised to the power m raised to the power n. So that is not a raised to the power m plus n. That is incorrect. Many students does that. That will be m into n. Clear? Fourth one is product of powers. Product of powers means product of powers like a raised to the power m into b raised to the power n. Okay, a raised to the power m into b raised to the power m. We have different bases here, but same powers. Different bases, same powers. Firstly, multiply the bases and take the powers as common. So a m b m equals to a b m. Fifth law, that is quotient law. Quotient of a powers, not quotient law. Quotient law is different. That is second law. Fifth one is the quotient of a powers. So a m b m, same like product, but here the difference is you are taking division. Here you are taking multiplication. So a b, first take the division and then take the powers. So a m b m equals to a upon b raised to the power m. Sixth one is the zero power. Zero power means any number raised to the power 0 is always 1. Clear? Clear? Any number raised to the power 0 is always 1, but here a cannot be 0. This one you should remember. A cannot be 0 here because 0 raised to the power 0 is indeterminate. 0 raised to the power 0 here is indeterminate. So any number raised to the power 0 equals to 1. So all 6 laws are clear to you. Shall I move to the next topic now? Any doubt you can ask me in the chat box. Any doubt? No? Okay. Now let's come to a very important topic, that is the notation. How to write the big numbers and the small numbers. Right? This is also application of exponents, right? This is what we are studying. That what are the uses of exponents here? So this is important. Why? Because this is one of the applications where I'll use the powers of 10. Okay? See how? Suppose we have a big number. Big number. Where do we see a big number, sir? Obviously, when you have to find the distance of Earth from the Sun, what is the distance between the Earth and the Sun? It's a very big number, right? So, should I write all the numbers? Should I write all the numbers? No. Suppose if I'll be given size of a red blood cell, it's a very small number, very small number, right? So how to write this very big large number, very small numbers? There will be some notation, right? Everyone should follow. So that is called the powers of 10. You have to write these numbers as powers of 10, and this is a general notation everyone follows. That is called the standard notation, okay? Or you can say that is standard form. So next we will study about the standard form. So what is a standard form? A number is in standard form when it is written as k into 10 raised to the power n. K into 10 raised to the power n, where k belongs to 1 to 10. Sir, समझ नहीं आया? K belongs to 1 raised to the power 10. What is the meaning of it, sir? Why only 1 raised to 1 between 1 and 10, where n is can be any integers? Let me tell you. Suppose examples I am writing, standard form, I am writing some examples. 5 into 10 raised to the power 5, 8 into 10 raised to the power 7, 3 into 10 raised to the power minus 3, 5.7 into 10 raised to the power minus 8, 3.2 into 10 raised to the power minus 10, 3.714 into 10 raised to the power minus 20. These are some examples of the standard form, how you denote the large numbers. This is a large number, this one is a large number, these are the small numbers. Why? Because the powers are negative here. Powers negative means the powers of 10 are in denominator, right? The property you have used, 10 raised to the power minus 3. If you want to make it positive, what you will do? I'll write this as 10 raised to the power 3. So you have to divide 3 with 10 raised to the power 3 here. So it will be very small number. Here also it will be a small number because we have to divide with 10 raised to the power 8. That is a very small number. 10 raised to the power minus 10. Even a smaller one, 10 raised to the power minus 20. Means these numbers are very small. And these are big numbers, but these are the general notation. So instead of writing numbers like this, you have to follow this pattern of standard form. Clear to you? N is positive for large numbers, negative for small numbers. So that is why I have written n equals to negative for small numbers. These are small numbers. And these are the large numbers, right? These are smaller and these are large. Also called as the scientific notation in science subjects. So I hope you all have studied in science that somewhere it is written like this, 10 raised to the power something, can be negative, can be positive, depends on what we are denoting, big numbers or small numbers, okay? So these are very useful in physics, chemistry. These are often used, okay? So it is called a scientific notation. So this is clear to you? Now let's write a large number into a standard form. So suppose if I have to express 149,600,000 in the standard form, how will I do it? कैसे करेंगे? सबसे पहले क्या करना है? The first step will be where should I put the decimal, right? So 149,600,000, right? This is what I have to write in standard form. This is a big number. The power of 10 will be positive only, right? Remember, if a number is big, the power of 10 is positive. If numbers are small, the powers of 10 are negative. So 149,600, what will be the first step that I will follow? Put the decimal on these numbers. So I told you the decimal will be after the first digit. So after the first digit, if I'll put, so 1.496. After that, what will be the power of 10, sir? I'll write all non-zero number. I'll write all non-zero numbers. So 1.496. Now the next question is, what I should give the powers of 10? So the powers of 10 will be just simply count the number of terms after the decimal. So you have given decimal here. So 1, 2 in the right side you have to count the number of terms. So 1, 2, 3, 4, 5, 6, 7, 8. So what will be the power of 10? It will be 8 only. So 149,600 000 can be written as 1.496 into 10 raised to the power 8. So this is the standard notation how you will write a big number. Firstly, what you have to do, you have to put a decimal right after the first digit. First non-zero digit. Okay, 1 is a non-zero. So we should give decimal after 1 only. Clear? I hope this is clear to you. Now let's come to how to write a small numbers in standard form. Same process you have to follow. Suppose if you have to write 0.000007 into standard forms, what I'll do? So first step is, which one is the first non-zero term? Which is the first non-zero term? The first non-zero term is 7. So I'll put decimal after 7. ये मेरा फर्स्ट स्टेप रहेगा, ठीक है. After 7 I'll put the decimal. So 7.00 something. Either you write or don't write, doesn't matter, right? After 7 there is no digit. So 7.000 will be there. So you can write also or you can neglect also. Now the next question is, what will be the power of 10? So I told you, when you have a small number, the powers of 10 will be negative. So यहाँ 10 का power negative number होगा. But क्या होगा sir? कौन सा number होगा? So simply what you have to do, original power is small, the exponent becomes negative, right? So count places the decimal point moved to the right. Just count how many places the decimal moved. So 1, 2, 3, 4, 5, 6. 6 places it moved. So I have to give power as -6. Understood? Understood? Once again I am repeating what I did. So 0.000007, if I have to write this in standard form, the first step will be where I should put decimal. So I have to give decimal right after the first non-zero digits. So it is 7. So 7 point something. So 7.00. Here we have nothing. No any non-zero numbers, right? After 7. So I'll write 7 only. So 7 into, now the next question is 10 का power क्या होगा? 10 का power क्या होगा? So 10 का power negative होगा. Why 10 powers will be negative? Because it is a small number. Since it is a small number, the power of 10 will be negative. So कितना negative होगा sir? So just simply count the number of digits the decimal jumped, or the number of digit the decimal point moved to the right. So 1, 2, 3, 4, 5, 6. So 7 into 10 raised to the power -6. Clear? We have done the majority part of this chapter now. Okay? Only we are left with the questions. Now let's come to the reverse part. We have, what we have done till now? Usual form we have written in the standard form. Now what I will do? I'll take the standard form and I'll write in the usual form. So suppose 3 into 10 raised to the power 4. I want to write in the usual form, simple notation. So what I'll do? Count how many 10 you have. 4 10. Decimal. 1 decimal. So move decimal right after 4 places. Power of 10 is positive here. Observe, power of 10 is positive here. So move decimal right after 4 places. So 34 000, right? Why? Because if I'll remove this decimal 1, if I'll remove this decimal, see here 3.4 into 10 raised to the power 4. What it says? Move decimal right 4 places. So right 4 places means 3 4, 1 place, 2 place, 3 place, 4 place. Simple. So 34,000 is the correct answer for this. 34,000. Next one is 6.1 into 10 raised to the power minus 3. This is a big number. For small number, how will I write? For small number like 6.1 into बात करते रहे. Okay. Teaching related. Okay. So we were talking about the standard form and the usual form, right? So here we have 3.1 into 10 raised to the power 4. If I have to write this in usual form, what I'll do? Simply once again I am repeating it. You have to take the powers. Firstly see the powers and then you have to move to the right. Suppose 3.4 into 10 raised to the power 4. What you will do? Move your decimal right 4 places, it's saying. Means 3.4 into 10 raised to the power 4. This is what you have to do for big numbers. What for small numbers, sir? For small numbers, suppose 6.1 into 10 raised to the power into 10 raised to the power minus 3. So 6.1 into 10 raised to the power minus 3. How will I write it into the standard, not standard one, into usual one? Because this is a standard notation and this is a usual notation. So I'll move decimal left 3 places. Left 3 places means, sir, if I'll write this as 0.0061, 0.0061. So what I did here? I have moved decimal left 3 places. See how? 6.1. There was decimal after 6. So just move 3 places. 1, 2, 3 into the left. Or simple should I, what I should, if I'll take something that 6.1 into 10 raised to the power minus 3. इसको simple में कैसे करें sir? So simply what you will do? 6.1, one property you know, make it positive. So for that what you will do? 10 raised to the power 3, that is positive. So it will be simply, if you will remove this decimal, once again it will be 10. So 61 divided by 10 raised to the power 4. Divide it, 0.0061. This way also you can follow. 0.0061. 0.0061, right? So rule of thumb is positive exponent, move right, negative exponent, move left. If you are feeling hard for this rule, just simply you can follow this one also. Clear? I hope this is clear to you. Let's solve some problems that what we have done so far. First question is simplify the following expressions. 4 raised to the power minus 2 into 4 raised to the power 5. Kiran? 4 raised to the power minus 2 into 4 raised to the power 5. So it will be, see here, bases are same. If you'll observe, the bases are 4, powers is different. So you remember the first law, that is the product law. So take the bases common, that is 4, add the powers. So minus 2 plus 5. So minus 2 plus 5 is 4 raised to the power 3. So 4 raised to the power 3 is basically 4 cube, and we know the 4 cube is 4 into 4 into 4. Multiply same number 3 times, which is 64. So first question is done. See how simple this is. This is how you have to do questions on laws of exponents, and this is one of the important points for this chapter. Second one is 3 raised to the power 2 raised to the power 3 divided by 3 raised to the power 4. So 3 raised to the power 2 divided to the power 3. Powers of a power. So just simply multiply it. So 3 to the power 6 divided by 3 to the power 4. Now which law I will use here? Quotient law, because bases are same. 3. Powers are different. So 3, 6 minus 4. 3 square, and it is 9. Verify it is correct or not. I hope it is correct. 3 power 2 power 3, 6 divided by 3 power 4. So 3, 6 minus 4, 9. This is correct. Simple. So this is done. Now let's come to the third question, and that is simplify the following using laws of exponents. 2 power 5, 5 power 5. If you don't remember the name of the rule, doesn't matter, just remember the concept. Here if you will see, 5 to the power 5 is there. 5 to the power 5 is there, right? Five to the power 5. So powers are same. Only the difference is bases are different. So what I told you, just multiply 2 and 5. 2 and 5 को multiply करो और powers को same रखो. So 2 into 5 means 10 raised to the power 5. That is 10. This is what you will get. 1, 2, 3. This is what you will get. 1 lakh. Next question. See how simple these questions are. And now just try all the questions of grade 8. You will attempt almost 98% or 99% of the question. I can guarantee. Express the following numbers in standard form. Standard form you have to express means you have to write it in the powers of 10. So 520, what I told you in the first step, you have to do, put the decimal at the right position. Right position means after first non-zero numbers. What is the first non-zero number? That is 5. So 5.2 into 10 raised to the power. Now the next question is 10 का power क्या होगा? 10 का power, just count where you put decimal. So that is basically here 5 point something. So count 1, 2, 3, 4, 5, 6, 7. So 10 raised to the power 7. So 5.2 into 10 raised to the power 7. Clear? Next one, write the following number in the usual form. Now you have to write this into the usual form, not standard form, because this is already in standard form. Okay? This one is in standard form. What will be the usual form means just write the number that you are getting. So 3.7 into 10 raised to the power minus 5. What I told you, if you will feel difficult, make it positive. So 10 raised to the power minus 5 means 10 raised to the power 5. 10 raised to the power minus 5 means if you will make it positive, take the reciprocal, it will become positive. Next step, remove the point. So 37 divided by 10 raised to the power 6. So it will be 0.000037. 0.000037. Understood? If you will divide it, because if you will remove the decimal here, how many zeros you will have? 1, 2, 3, 4, 5, 6. Remembered only the first one. Just remember the first one. 1, 2, 3, 4, 5, 6. So this is how you have to do in writing the standard form to the usual form. Clear? Now let's move on to the next question. These are the NCERT's problems. New NCERT's book, if you are following Ganit Mazari book, then you are given these problems. 6 into 6 into 6 into 6. This is, you are multiplying 6 4 times. So what you will write here? 6 to the power 4. Where 6 is a base and 4 are exponents. Clear? Y into y means you are multiplying 2 times y. So y power 2. B into B into B into B. Multiplying B 4 times. So B power 4. 7 B into 5. So it will be B into 5. 7 to the power 3. How many 7 we have? We have 3 7. So 7 raised to the power 3. 2 into 2, A into A. Means 2 power 2 into A power 2. Means I am writing this into the exponential form. Here we have given it into the product form, or each number is written into the product form. I am writing it into the powers of some numbers. Here it is A into A into A. How many times? 3 times. So A power 3. I can write C into C into C into C 4 times. So C power 4. D is coming only 1 time. So this is D power 1. Clear? Let's move on to the next question. That is, write the numerical value of each of the following. See how simple these questions are. If you understand the concept, these questions are really very simple. Yes or no? Simple. Obviously. First one is 2 into 10 raised to the power 3. 2 into 10 raised to the power 2. You have to write the numerical value. Now you have to write numerical value. So 2, how many zeros we will have? 1, 2, 3 zeros, right? Because 10 power is 3. So we have to give 3 zeros to this number 2. 7 into the power 2 into 2 raised to power 3. 7 power 2, 7 square is 49. 2 power 3, 2 cube is 8. So just multiply this number. 49 into 8, you will get the number. So 49 into 8 is 2. (49) into 8 you have to do 392. Check once. Yes, 392. 3 into 4 raised to the power 4, which is basically 3 into 4 power 4 is 64, right? So 64 into 3, 4 into 3, 12, 6, 3, 18, 1, 19, 192. Simple. Minus 3 power 2 into minus 5 power 2. Once again it is simple. Minus 3 power, even power is there. See here, there is an even power. So the numbers will be positive. That is 9. Minus 5 square. Once again it is an even power. So it will be 25. So 25 into 9 is 125. Simple. Next one is 3 square into 10 raised to the power 4. So 3 square is 9. 10 power 4. Means you are multiplying with 10,000. So that is 90,000. Yes, it is 1, 2, 3 after 3. zeros, there will be commas. Clear? That is 90,000. Last question is minus 2 raised to the power 5 into minus 10 raised to the power 6. So minus 2 power 5, power is odd here. So minus 2 power 5 will be some negative number into 2 raised to the power 5. Obviously it will be minus 2, minus 32, right? Into 10 raised to the power 6. This will be, because powers is even, so this will be a positive number. So minus 32, 60, 3, 4, 5, 6. This is how you have to deal with the question. So I think all kind of questions we have done in this class, right? So now just try all NCERT's problem, all NCERT's problems, and we are done. You can try all NCERT's problem now. Let's solve the last one, that is 2 minus 4 into 2 raised to the power 7. Minus 4 plus 7, that is 3. Yes, minus 4 plus 7 is 3, 8. Once again, bases are same, just you have to add powers using the laws. So 6 plus 2, 8 minus 5, that is 8 minus 5 is 3 raised to the power 3, 27. P raised to the power 3 into P raised to the power minus 10. So P3 minus 10, bases are same, you are adding the powers, P minus 7. Or you can write 1 upon P raised to the power 7, same thing. 2 power 4 into minus 4 raised to the power minus 2. Now this is important. Now this is important. Why? Minus 4 raised to the power minus 2. 2 raised to the power 4. What I told you, when we have negative powers, to make it a positive, minus 4. Just take the reciprocals. So if I'll take the reciprocal of this number, it will be 1 upon minus 1 upon 4 raised to the power square. Because minus was already in present, no? So minus 4 raised to the power minus 2 will be basically minus 1 upon 4 raised to the power square. So 2 power 4 into 1 upon 16. So 2 power 4 is 16 only. 1 upon 16. So 16 will get cancelled and it will be 1. 8 raised to the power p into 8 raised to the power q. Bases are same, so just add the powers. So this is how you have to deal with all the questions. This was also an NCERT's problem. Express the following in standard form. This one I am giving you as homework. Please try by yourself. That's it. Standard form you have to write. I have given the concept. You have to put the decimal at right position and you have to give the powers of 10. I hope we are done. Yes. Any doubt related to today's class, you can ask me. Then I'll finish the session now. Any doubt? Or should I finish the session? So let me tell you once again about the Sisya classes. If you want more such interactive sessions and free sessions, please explore our booster courses, Maths Champ courses or Sisya Topper program, because there you will see many IITs and NITs teachers and you can have a very bright future if you study from the Sisya classes. Okay, simply what you have to do, visit the sisyaclasses.com/LTC, then enter your grades, tap on it, you will get a pop-up option. There you have to fill in the mobile number and your state name. And at just ₹19 only, you will get 3 demo classes. Just test it and then enroll for it. Okay, that's it. If you like this session, please like it, subscribe it, and share with your friends as well. Please subscribe the Sisya class channel. 7th, 8th, 9th. 7th, 8th, 9th channel. Please subscribe the Sisya classes. Thank you so much, everybody. Have a good day. Thank you.